Hello, I'm Albina Zavgorodniaia.
I am Rodrigo Duran.
And I'm Otto Seppala.
We are going to discuss one of the most commonly used theories in computer education research, cognitive load theory. The structure of the presentation is as follows. Firstly, we'll briefly introduce cognitive load theory, then we'll discuss cognitive load measurement instruments, including the one developed for the computer science domain. After, we will present the research questions and discuss results and future research.
Cognitive load theory is an influential branch of educational psychology that has become one of the most frequently cited theories in computing education research. The theory emphasizes that there are severe limits to human working memory. From that premise, it derives various empirically grounded recommendations for teaching and learning. For instance, studying worked examples imposes less cognitive load on learners' working memory than problem solving does. Since examples nevertheless lead to effective learning, cognitive load theory recommends studying examples over problem solving when the learner's prior knowledge is low.
In order to study cognitive load effects and evaluate pedagogies based on cognitive load theory, it's useful to measure cognitive load. For measuring cognitive load, we need validated instruments. For measuring cognitive load in a computing context, such as introductory programming, we need instruments validated for those contexts. Our paper contributes towards those goals. We can't directly see cognitive load in human brain. What we can do is measure something related and see if that measure works as a good enough proxy for cognitive load. One of the most common ways to do that is to ask learners to evaluate their own mental effort immediately after a learning activity. Here's an example. This simple question has been used in many studies to good effect. However, single-item surveys tend to provide noisy data. Moreover, this question is about overall cognitive load, whereas researchers would often like a more nuanced picture. Here's another survey instrument. This one targets 3 different components of cognitive load, each with several questions. 3 questions target intrinsic load, which is the part of cognitive load that cannot be reduced without compromising learning goals. Another 3 questions target extraneous load that results from suboptimal teaching. And finally, 4 questions target so-called germane load that is indicative for learning. As you can tell, this instrument by Morrison has been adapted to the programming domain. It has been used in a number of computer education studies. I will only mention here that scholars have different views on whether the third component, germane load, can be considered a genuine cognitive load component, or if these questions measure something else entirely. For more on that debate, please see our paper.
In this study, we collected data using this computer-specific instrument by Morrison to investigate 3 things. First, we looked at the instrument's internal reliability. Do the items that target intrinsic load all measure essentially the same thing, a single construct? And does the same apply to the other group of items that target extraneous load? And what about the ones targeting germane load? Second, we looked at the instrument's discriminant validity. Does it measure 3 constructs as originally intended? That is, are there 3 different things being measured here? Those questions are inspired by Morrison's original study, which found support for both internal reliability and discriminant validity for this questionnaire, but has not been replicated. We replicate it here. Third, we look at discriminant validity from a different perspective. Are there in fact only 2 factors being measured here? Do the intrinsic load targeting and germane load targeting questions in fact measure more or less the same thing? A recent language learning study by Jiang and Kalyuga, which employed a similar cognitive load questionnaire, suggests this interpretation. We replicate their analysis in the programming domain, so our paper is, in effect, a double replication.
We crowdsourced participants to evaluate an instructional video which presents beginner-level lessons to reading Python code in English. We took extra steps to guarantee our data quality by recruiting participants with excellent rates and experience, participants with no or minimal programming experience, and we excluded participants who completed the experiment too fast or answered the questionnaire in suspicious patterns. Our final sample consisted of 175 workers, 44.4% men and 55.6% women. The majority were native English speakers from US and India. Most of the participants held a bachelor's degree in humanities and were between 25 and 54 years old. Our participants first completed a demographic survey and then watched a 24-minute pre-recorded video presentation. The video introduced the concepts of variable, expression, and value, and taught the participants to reason about short fragments of imperative code consisting of assignment statements and print comments. It covered several short example programs, explaining the code constructs and tracing each other program's behavior in detail. Finally, participants completed the Morrison and colleagues' cognitive load questionnaire. We performed a confirmatory factor analysis to evaluate which factor arrangement best fits our data. A two-factor model, with questions targeting intrinsic and germane load grouped into a same factor, and questions targeting extraneous load forming a separate factor, or a three-factor model, in which questions from each of the loads are treated as distinct factors. So, let us look at our results. First, all questionnaire items are internally consistent, with a Cronbach's alpha of 0.87. However, factors in the three-factor model were more reliable. When grouping intrinsic and germane load, our results show a decrease in factors' reliability. Second, when analyzing the model fit parameters, all parameters in the three-factor model can be considered good, as you can see in green, with the opposite happening in the two-factor model. You can find more details regarding the parameter analysis in our paper, and an ANOVA test confirmed that a three-factor model is significantly better fit compared to a two-factor model for our data. Finally, the analysis of factor loads shows that all questions have a very good loading into their factors. While we found a moderately significant correlation between intrinsic load and extraneous load, and between extraneous load and germane load, as you can see in our figure, we did not find a correlation between intrinsic load and germane load questionnaire items.
Overall, our results strongly support the idea that Morrison's computing-specific variant of the cognitive load instrument is internally reliable and has good discriminant validity. In these respects, computing educators and researchers can use the instrument with increased confidence, which is good news since papers are being published in computing education that rely on this instrument. Given that our data did not fit the two-factor model proposed by Jiang and Kalyuga, it seems likely that the instrument discriminates between three different constructs rather than only two. The good news aside, we believe it's important to stress that our study did not evaluate the instrument's construct validity. That is, although we may be confident that Morrison's instrument and others like it in the psychological literature are reliable, and although we may be confident that they measure several distinct things, it remains only partially substantiated that those distinct things that are being measured are actually a good proxy for cognitive load components. Indeed, there are some significant question marks over the construct validity of self-assessed cognitive load in general and supposed germane load measurements in particular. We discuss this at some length in the paper. Future research should explore the construct validity of cognitive load measurements both in computing education and more broadly. We also recommend that cognitive load surveys are accompanied by a motivation survey, perhaps as a replacement for the questions that target germane load. In the paper, we contribute a discussion of some current trends in cognitive load research, which we believe researchers in computing and education should be aware of when using the theory. Please see the paper for more on that.
Thank you for your attention.